We're going to start once again discussing our learning target, which is to classify the types of chemical reactions. As far as our success criteria, it is going to be very, very similar to what we discussed yesterday. So if you remember yesterday, our very first one was to be able to balance chemical equations. Our second success criteria was then to describe and identify a synthesis reaction. Well, today it's going to be to describe and identify a decomposition reaction. The final success criteria yesterday was to be able to predict the combination/synthesis. So the final success criteria today is going to be able to predict a decomposition reaction. Now, I think that these are some of the tougher ones to do because you just have to memorize your basic ideas. Now, here are our six decomposition reactions right here, 1 through 6. So as we look at these, okay, there are specific things we need to be able to identify. The very first one up there, a metallic carbonates. So it's dealing with the polyatomic ion CO3. Metallic hydroxides are the second one, dealing with OH minus polyatomics. Metallic chlorates, ClO3 minus 1. Metallic nitrates, okay, NO3 minus 1. Oxyacids, we discussed the composition of those. Oxyacids are just acids that are dealing with oxygen and some other element. And finally, the decomposition of a binary compound. So those are the 6 different types of decomposition reactions that we're going to be dealing with. So as we come back up, let's look at this very first one. Okay, go ahead and write that into your notes. Zinc carbonate. Now, as I'm dealing with zinc carbonate, I am going to first of all come back and look and say, okay, I have a metallic carbonate heated. So this is a decomposition number 1 reaction. Decomposition number 1. And it tells me that when I heat a metallic carbonate, I get a metallic oxide and carbon dioxide. So as I come back, I said this is a decomposition number 1. So zinc carbonate, which is ZnCO3, it is heated. Now, if I don't heat this, I do not have the amount of energy that is required to decompose zinc carbonate. So if I have zinc carbonate sitting in a beaker, it's not going to decompose. I need to put some fire on it. I need to heat that. So we signify that as a triangle above the yield sign. So that triangle tells me that I need to heat this in order to get the energy necessary to decompose. Now, my metal carbonate gives me a metal oxide and carbon dioxide. So I'm just going to write metal oxide and CO2. Well, I know specifically what my metal is, don't I? What is my metal in this particular problem? Zinc. Excellent. So my metal oxide is going to be zinc oxide. So in my thought process now, I know zinc is a 2 plus, oxygen is a 2 minus, so my zinc oxide is going to be ZnO. Excuse me. Now I'm going to go back, I'm going to step back, and I'm going to look. Is this a balanced chemical equation? Yeah, it is. Okay? So I have now written the equation for the decomposition of zinc carbonate. So zinc carbonate, when heated, will give me zinc oxide and carbon dioxide. My second one here, sulfurous acid heated. So I am dealing with an acid. As I look at my 6 different types of decomposition reactions, which one is dealing with an acid? Maya, which one's dealing with an acid? Number 5 right here. Ooh, I didn't mean to do that. Number 5 right here. An oxyacid heated will give me a nonmetal oxide and water. So this is a decomposition number 5. Decomposition number 5, I have to start off with sulfurous acid. IC 1 or 3? Well, I don't see an IC. So I see an OUS. So this is acid rule number 2. OUS tells me that I have an ITE ending, so I am looking for sulfite. Sulfite is SO3 2 minus. So how many H's do I need, Ashton? 2. So I'm going to have H2, and I'm going to get that charge out of there, H2SO3. It's going to be heated, so I put my triangle above. My yield sign. Now, getting back to my oxyacid heated, it gives me a nonmetal oxide and water. So I have a nonmetal oxide and water. Well, when we did this yesterday, we added water to our nonmetal oxide. So today, we're going to take this H2SO3 and we're going to pretend we're subtracting H2O. Once I do that, I get rid of those H's and I get rid of one of my O's. So it's going to give me SO2. See how I did that? Almost like I'm just subtracting a water. So my nonmetal oxide up here is going to be SO2. I'm going to clean this stuff up on the bottom there. I'm going to step back, and since I just subtracted water from that H2SO3, I should be balanced, right? Okay. My next example, aluminum chloride heated. Once again, let's head back to my decomposition reactions and go through these. Drake, what do you think? 1 through 6, what am I dealing with here? That is a common one that we're going to think about here because, okay, obviously we don't have 1 or 2, do we? Now, as I go back here, Drake, am I looking at a chlorate? I am not, am I? So, do you still think it's number 3? No, it's not number 3. I don't have a chlorate. I have a chloride, which is very, very close. But is Cl minus 1 the same as ClO3 minus 1? No. Okay. Is it number 4, Drake? 5? So it must be what? Must be a decomposition number 6, which is a binary compound. So when I come back, I put decomposition number 6, a binary compound. Well, all a binary compound is it's just made up of 2 elements. So I'm going to put aluminum chloride, AlCl3. This time it is electrolyzed. Okay, we're going to do a demo sometime next week on how we electrolyze something. But to electrolyze it, I just put this little wavy line above my yield sign to show that I have an electrical current. Now, as I come back, I guess I get highlighted my right one. Binary compound, when it is heated or electrolyzed, will give me constituent elements. Well, what does that mean? What does constituent elements mean? That just means it splits into the 2 different elements. So, I had aluminum chloride. It is going to split into aluminum, and it's also going to split into chlorine. Now, the key part with this is I need to check for what? Anybody know what I need to check for? Caitlin, what do you think? Well, you look like you had something you wanted to say. Ashton? Super 7s, absolutely. Do I have a Super 7 here? Yeah, what is it? Chlorine, right? Chlorine's a Super 7, so he's a diatomic. I have to make sure I have that diatomic in there. So now I'm going to need to do what, Paige? Huh? Yeah, I need to add coefficients because I'm not balanced, am I? I can see an even-odd problem with my chlorine. So I'm going to make this odd even. Give me 6. That means I'm going to have to put a 3 there to give me 6. And if I put a 2 here, I have my aluminums balanced. Can I reduce, Paige? No. So do I have a balanced chemical equation now? Sure do. Sure do. So that is the electrolysis of aluminum chloride to give me my constituent elements. Next up on my chart is sodium chlorate. Now these are somewhat easy to pick out, but they're harder, like I said. Okay, which one am I dealing with here, Ella? Decomposition number? You blanked out? Well, let's go back here. Got her? It is what? 3. So this is a decomposition number 3. A metallic chlorate will give me, when it's heated, will give me a metallic chloride and oxygen. So I have decomposition number 3, sodium chlorate. When it's heated, it's going to give me a metal chloride and oxygen. Remember, oxygen's a super 7 also. Oxygen's a diatomic, so we have to have that O2. Ella, what is my metal I'm dealing with? Sodium. So I can replace that. It's going to give me sodium chloride. So my formula for sodium is Na1 plus, chlorine is Cl1 minus. So my sodium chloride is going to be NaCl. Clean her up a little bit. Now my final thing I need to do is what, Ella? Balance. Okay? Balance. Do I need to balance here or am I okay? I need to balance because my oxygens right now are not good. So I got this odd one I need to make even. Once I do that, that gives me 6 oxygens. I'm going to save that oxygen for last because it's by itself. I'm going to put a 2 here. I'm going to put a 3 here. Is it balanced now, Ella? Yes. Yes, it is balanced now. My next example is going to be for you, Will. Potassium nitrate heated. That would be a decomposition number 4. Now, one thing. Look at your outline on decomposition number 4. It says, a metallic nitrate heated will give me a metal oxide, it'll give me nitrogen dioxide, and it'll give me oxygen. Except for group 1 below lithium. These convert to nitrites and oxygen. So there is an exception here. So I know that this is a decomp number 4, like Will said. So I'm going to put a D number 4 up here. I need to look. Am I dealing with a group 1 element that is below lithium? Am I? I am, right? So this is my exception. So I'm going to take my potassium nitrate, KNO3. I'm going to heat it. So I got my little triangle there. And my exception says that if I have group 1 below lithium, these convert to nitrites and oxygens. So it's going to give me a metal nitrate and oxygen. Oxygen's a diatomic. What is my metal here, Will? Potassium, so I can substitute that in there. So it's going to give me potassium nitrate, and oxygen. Well, I know that potassium is K1 plus. I know that nitrite is NO2, 1 minus. So I am going to get my potassium nitrite is going to be KNO2 and water. Clean it up a little bit. I can bet here that I've got some problem balancing. So KNO3, KNO2 plus O2. I can see that I got some issues with my odd here. So I'm going to start off by making that an even here, giving me 6 oxygen. I know that I now have changed my potassium. I need 2 potassiums. So 2 potassiums, 2 potassiums, 2 nitrates, 2 nitrogens, 2 nitrogens. That gives me 6 oxygens on my reactant side. 2 and 2 is 4 plus 1 is 6. It appears to me that I have this guy balanced now. So that is the exception here, ladies and gentlemen. The exception to decomposition rule number 4. All right, the very last one, Kaylin, aluminum hydroxide heated. Which of my decompositions is this one? It's a decomposition number 2. A metallic oxide heated will give me a metal oxide and water. So, I forget what we said, 2? Is that what we said? Decomposition number 2? So, a metallic hydroxide, when it's heated, once again, when it's heated, it's giving me a metal oxide and water. Metal oxide and water. Kaylin, what is my metal? Aluminum, so it's going to give me aluminum oxide and water. So now all I have to do is figure out what this aluminum oxide is. Well, I know aluminum. Aluminum is a 3+. I know oxygen is a 2-. So to get my charges equal to 0, I'm going to need to have a total of 6+ charges and 6- charges. So I'm going to make that 2 and 3. So my aluminum oxide is now going to be Al2O3. Clean it up. Now I need to look at some balancing, because obviously I don't have this balanced. I can see that my very first problem is that my aluminums, I first of all would look right here at my polyatomic. I don't have a hydroxide on both sides though, so I can't keep that polyatomic together. I need to split it. First thing I'm going to do is I am going to balance up my aluminums. When I balance up my aluminums, I put a 2 here, so I have 2 aluminums on both sides of my yield. Once I do that, that gives me hydrogens and oxygens left. 3 and 2 is 6 hydrogens on this side. Oxygens, 3 and 2 is 6 oxygens, right? So I have 6 hydrogens, 6 oxygens. As I look over here, I have 3 oxygens there. So if I put a 3 here to give me 6 oxygens, that works out pretty good, doesn't it? With the 6 and 6. So I'm saying that now I have a balanced chemical equation. So aluminum hydroxide, when heated, will give me aluminum oxide and water. Questions? Now, ladies and gentlemen,